Hi, this is Rajshekhar, Assistant Professor in EEE Department. Through this video, I am going to demonstrate how to write a code for formation of Ybus using SCILAB. This video will help the students to expertise in coding and how to know and write a code for any type of problem they face in their part of engineering curriculum. Let us write a program for Ybus taking one problem. I have taken this problem from Nagarath and Kodari textbook where from 1 and 2 there is a transmission line connected. Between 1 and 3 another transmission line is connected. Like that, this problem is taken from a network. Let us see how this network looks like. So from between 1 and 2 there is a line connected. Now in the second row between 1 and 3 there is a one line connected. So between 1 and 3, so now a third node has come into existence, and between 1 and 3 there is a transmission line, and between 2 and 3 there is a another transmission line connected, and between 2 and 4 there is one more transmission line connected, and this is the fourth node, and between 2 and 4 one more, and the last row 3 and 4 there is one more transmission line connected. That means this entire network whose admittances are known are tabulated as shown in the table. So from this table, how many nodes are there? There are 4 nodes, 1 2 3 4, and there are total 5 branches. So for a 5 branch 4 node network, the Ybus will be having a order of 4 by 4. So we can see here I have taken one matrix which is having the number of rows as 4 and number of columns as 4. Since the number of nodes in the network is 4, now between 1 and 1 there is some admittance called Y11. Similarly, Y22, Y33 and Y44 are the admittances of each node. Y12 represents the mutual admittance from the node 1 to the node 2. That means if there is any line connected between 1 and 2, then that is represented as Y12. Since it is a symmetric matrix, Y12 is equal to Y21 and Y13 is equal to Y31. Like that, this Ybus matrix is formulated. Now our task is to write a program to fill all these elements in this matrix. So in this I have represented the from and to columns with different colors. So here from 1 to 2 it is Y12. Similarly, as I told you, Y12 is equal to Y21. I have represented with same color. Y11, Y22, Y33 and Y44 are diagonal elements, and Y13 is nothing but that is the admittance connected between 1 and 3. So here Y13 and Y31, and green color Y23. So here Y23 and Y32 are same. So once you know Y12, you can get Y21. If you know Y13, you can get Y31. Similarly, all the elements can be calculated. You can see here the fourth Y14 is 0 because between node 1 and node 4 there is no line connected. So here the element will be 0. Now, what is y11? Y11 is nothing but, see here, here first node is there. For this node, how many elements are connected? 1 and 2. So, the y11 is nothing but the sum of the admittances of these two elements. So, y11 is equal to y12 plus y13. Similarly, if you observe node 2, there are 3 elements connected to this node. So, the sum of the admittances of the 3 elements connected at that node gives the diagonal element value y22. Similarly, y33, if you observe, there are 3 elements connected, and similarly at node 4, y44, only 2 elements are connected, that is y24 and y34. So these are the equations to calculate the diagonal elements, and off diagonal element values are given in this table. Now, step by step, we will calculate the off diagonal elements, or we will assign the values to the off diagonal elements. So what I have done is, I have taken this part, first 2 columns, and expanded here, and see, you can see 1 and 2, let 1 goes into m and 2 goes into n. So ymn represents y12, because 1 is going to m and n is going to 2. So y12 is equal to y21. y12 and y21 are nothing but the values of g plus jb of the particular row. Now 2 minus j6 is nothing but the admittance y12. Now uh, the minus of that value we have to enter here. Likewise, now I got the first 2 elements from this table. Similarly, if you go to the second row, 1 and 3 are written. So 1 and 3 here, 1 goes to m and n goes to, 3 goes to n. So y13 and y31 are nothing but the corresponding values of g and b of the particular row. Now, like that, we can proceed for all the values which are given in this table. So finally, likewise, if you go on step by step, finally we reached 3 4 3 4. Now m becomes 3 and becomes 4. y34 is equal to y43 is equal to the corresponding values of g and b, and all the off diagonal elements are filled. Now to fill the diagonal elements, as we know the formula earlier discussed, y11, if you want to find y11, how to identify how many nodes or how many elements are connected to this first node. So the first node, see here, 1 is appearing in this entire table with 2 columns 2 times. That means 2 elements are connected. So what are the 2 elements? 1 2 and 1 3. 1 2 and 1 3. That means 1 2 corresponding admittance plus 1 3 corresponding admittance. If both are added, we are going to get this value y11. And if you want to know the how many elements are connected to this node 2, in order to calculate this y22, in these 2 columns 2 is appearing 3 times. That means 3 elements are connected to the node 2. What are the elements? 1 2 2 3 and 2 4. 1 2 2 3 and 2 4. When these corresponding admittances from this table are added, you are going to get y22. Now, to calculate the y33 value, that means corresponding third node. So how many times this 3 is repeating? 1 2 3. That means there are 3 elements connected to the node 3. And what are the elements? 1 3 2 3 and 3 4. So 1 3 2 3 and 3 4. The corresponding admittance values are added to get y33. Now for fourth node, so how many 4s are appearing in this table? 1 and 2. That means there are only two elements that are added, are there at the node 4. So 2, 4 and 3, 4 are only the lines connected to node 4. So the corresponding admittances are added to get Y44. So all the diagonal and off diagonal elements, how to calculate? I have explained the logic. So the logic for calculating the diagonal and off diagonal elements will be possible only when we define this matrix. So CLC means clear, clear screen. C, I am defining a matrix C, and whatever the table is shown, that table I have represented in a matrix form: 1 2 1 3 2 3 2 4 and 3 4. This is the matrix. That means I can retrieve the elements from this matrix, and this logic which I have written using for loop will determine the off diagonal elements, and the next logic which I have written here will determine the diagonal elements real values, and this logic will determine the uh, reactive part of the diagonal elements, and finally this will display Ybus and input. What are the input we have given and what is the Ybus obtained to the corresponding input. So this is the corresponding Ybus that is formulated from the input, that is, this is the input we have given as a C matrix. So 1 2 1 3 2 3 2 4 and 3 4 are the branches, the corresponding admittance values, and taking this this matrix is calculated. This is nothing but the Ybus of this network. So in the next slide I am going to show how to run this program in SCILAB. So this is the program where I have shown earlier. So C matrix is defined here, and Nn will get the size of the C matrix. K1 and K2 will get the values, maximum values in each column, and this entire process will calculate the number of nodes in the matrix or network. Similarly, as I told, this logic will calculate the off diagonal elements, and this logic will calculate this entire logic will calculate the diagonal elements, and finally I am going to display the Ybus and input. So I want all you students to type this program as it is and try to analyze so that line by line, so that the logic which I have used you can get it easily. Now I will run this program, and if I run this program and see the output, so this is the Ybus output on the console. So this is the corresponding output Ybus, and this is the corresponding input. And now the same program, if I increase the number of rows or decrease the number of rows, that means suppose if I remove this element, one branch but the number of nodes is 4 only, because 1 is connected to 2, 3 and 4. So what I am going to do is I am going to take only this matrix and run. See, let us see what will happen to the output. See, the input is changed. So earlier we have 5 rows, now it is only, I am giving only 4 rows, but the matrix I obtained is 4 by 4. 4 by 4 matrix. So for the program, what we are going to do is, now let me take out these two rows. That means this row corresponds to a branch 2, 4 and this row corresponds to branch 3, 4. That means when I am removing these two rows, means what I am doing, I am taking the node 4 out. That means now the nodes is 3 only. That means I should get 3 by 3 matrix. So the Ybus should be a 3 by 3 matrix. So what I have done is I have done one small error which I have not closed the matrix. So now I will execute, save and execute. Then what will happen? I should have to get a 3 by 3 matrix. So I got the output as a 3 by 3 matrix. Now 3 elements and 3 nodes. Similarly, this program can be used to calculate for n number of buses. Suppose there is n number of buses, then suppose n number of buses and m number of branches. Now this program will calculate the Ybus. Now again I have introduced the values. That means now the node 4 has been added to the network. Now I can see the output has changed. Now the input I have added 2, 4 and 3, 4. Now the Ybus has been changed. I got a 4 by 4 matrix because the maximum number of nodes are 4. Like this, we can calculate the Ybus for n number of nodes and m number of branches. That means for any network, we can calculate the Ybus using this code. Thank you. Thank you for watching my video, and please do subscribe to my channel to get more updates regarding the electrical concepts. Thank you. Thank you very much.